We will continue our lesson on the washer method, and before we look at revolving regions around the y-axis, let's do one quick review question. And this is a 2013 AP Calculus exam, and we're given these two functions. It says 2x cubed minus 6x plus 4 and 4 cos 1/4 pi x, and let R be the region bound by these two functions as shown in the diagram. And in question A, we want to find the area of region R. Again, this is a non-calculator question, so to find the area, it's equal to the integral. My limits are going from 0 to 2 of my top function minus my bottom function. Now, it doesn't indicate in the question which function is which, but by analyzing this guy and seeing that it's a 2x squared, it's a positive parabola, that has to be the bottom function. So when I set up my integrand, it's going to be the top function, which is 4 cosine 1/4 pi x minus the bottom function. Again, I have to put that in brackets. It's going to be 2x squared minus 6x plus 4, and I'm integrating this all with respect to x. So since we don't have a calculator, we have to do some manual integration. So I'm going to integrate cos, and the integral of cos is sine. So it's going to be, the area is going to equal 4 sine 1/4 pi x divided by the derivative of the inside, which is 1/4 pi, minus, and I'll wait to distribute the negative sign in a bit, the integral of 2x squared is going to be 2/3 x cubed. The integral of negative 6x would be negative 3x squared. And the integral of 4 is going to be plus 4x. And this is going from 0 to 2. To clean this up a little bit, I'm going to multiply by the reciprocal to the constant 4, and that's going to become 16 over pi sine of 1/4 pi x minus, now we'll distribute the negative, 2/3 x cubed plus 3x squared minus 4x, all going from 0 to 2. Now it's a matter of evaluating, so I'm going to plug in my upper limit, which is 2. So I'm going to have 16 over pi, the sine of 1/4 pi times 2 minus 2/3 of 2 cubed plus 3 times 2 squared minus 4 times 2. And plugging in the lower limit, every term will become 0, so that's irrelevant. So if I work this out, I get 16 over pi. This guy here becomes the sine of pi over 2, which we know is 1. Minus 2 cubed is 8 times 2 is going to be 16 over 3, plus 2 squared times 3 is 12, minus 8. And believe it or not, you could leave your answer like that, and that would give you full marks for the solution. You could simplify it further, and I believe on my notes I do simplify it further, but that is far enough for that question. Question B says it wants us to write but do not evaluate an integral expression that gives the volume of the solid when region R is rotated about the line y equals 4. This one's a little bit new because y equals 4 is the line which is above our region, so we're rolling this region upwards. So in that case, this is going to become my outer radius, and this part is going to become the lower radius. So just like before, to figure out the upper radius, I take the top of my region, the top of my slice, and minus the bottom. So in this particular case, I'm just going to move this over a little bit. My capital region R, the top of my slice is 4, minus the bottom of my slice is the function f of x, which is, I can just write it as f of x because it's defined as f of x in the question. And the smaller radius is going to be 4 minus g of x. I guess I really didn't need the double brackets here, so let me just clean this up here. Okay, so question B is asking us to write an integral expression, but we don't have to evaluate it. So if I set up the integrand to find the volume is going to be pi, the integral from 0 to 2 of my outer radius squared minus the inner radius squared dx. So it's the integral from 0 to 2. My outer radius was 4 minus f of x, and we have to square that entire thing. Subtract the inner radius, which is 4 minus g of x all squared with respect to x, and that would be your final answer. Okay, let's take a look at now how do we revolve things around the y-axis. Okay, and here's a kind of a picture. If we have some region R and revolving it around the y-axis, we kind of get a cone type of object. Okay, it's definitely going to be a washer if we were to take one slice and revolve it around the y-axis, because the slice is not touching the axis of rotation. And similarly with something like this, again, we revolve it around the y-axis. Again, we're not going to get a disc, we'll get a washer. So let's take a look at, this is our first example. So we have our two functions. The first function is our linear function, which is 4y, so it's already defined in terms of y. And my second function is y cubed. And we're revolving this region right here around the x-axis. So there is my one slice. And you can see that the y coordinates of the intersection points are going from 0 to 2. So therefore, to figure out the volume, it's going to be pi. I'll just pull the constant out right away. In the y direction, my limits are going from 0 to 2. And now we're going to rotate this around the y-axis. So rotating it around the y-axis, this would be my outer radius. So it's defined under the linear function of 4y. So my outer radius is going to be 4y squared. The inner radius is from here to the bottom of that slice, and the bottom of that slice is the function y cubed. So again, this would be y cubed all squared, and I'm integrating this with respect to y. So now, if I integrate this, I can use my calculator. So to work this all out, so it's the integral from 0 all the way to 2. And let's take a look here again. My outer radius was 4y all squared. So I have to open up a bracket. 4y, that whole thing is squared, minus, I have to open up another bracket. My second function was y cubed all squared. And I'm integrating with respect to y. So that results in 512 over 21. And if I times that by pi, the exact answer would be 512 pi over, I forget, I think it was 21, yes, over 21. So that would be my answer if I've revolved this around the y-axis. Now I know the question was asking which area is, or volume is greater, the x or the y. I just wanted to show you how to revolve this around the y-axis. So basically, to do revolutions around the y-axis is really no different than before. You have to indicate or find the equation in terms of x, and then we revolve around the y-axis. Let's try maybe one more here. Just make one up here. So let's say we have let's say we have the two functions. We'll draw our grid here. And let's say our first function is y equals root x. And our second function is y equals x squared. And we want to revolve this around the vertical line x equals -2. So again, we will draw slices perpendicular to the axes of rotation, and if I'm revolving that slice around the line x equals -2, obviously it's not touching the axes of rotation, so it's going to be a washer. So because I'm revolving around the y-axis, I need to change my equation. So I'm going to square both sides, and my first equation would be y squared equals x. My second equation, if I square root both sides, would be plus or minus root y is equal to x. And in quadrant 1, we just deal with the positive root y. So those are my two functions in terms of x equals. And now my outer radius, if I was to revolve this, would be coming from this far right side of my slice all the way to my axis of rotation. So I'm going to take the right edge of that slice, which is the function defined by root y. And I'm going to subtract -2, so that becomes +2. And my inner radius, which is this guy right here, is going to be the bottom or the left side of this slice, which is the function defined as y squared minus -2, which becomes +2. Next thing I need to do is find my intersection points. Okay, and to do that, I'm going to equate the function y squared is equal to root y, because they both equal x. Square both sides. Subtract the y over, factor out a y, and you end up with two solutions. Either y is 0 or y is 1, and those are going to become my limits on my integrand. So let's set up our volume now. So our volume is going to be pi, my integral from 0 to 1 of the outer radius squared minus the inner radius squared, integrating with respect to y. So my outer radius, or the big radius, is root y plus 2. So root y plus 2 all squared minus the inner radius was y squared plus 2. And I'm integrating with respect to y. There's supposed to be a bracket here. Okay, so let's just punch this into the calculator and see what we get. So I need to calculate a definite integral going from 0 to 1 of, open up my bracket, I believe it was the square root of y plus 2, and I have to square that, minus, open up another bracket, and this was y squared plus 2, I believe, from my lower radius, or smaller radius, yes, y squared plus 2. And I have to square that, and I am integrating this with respect to variable y. If I get an answer here, it works out to be 49 over 30. And then I would multiply that by my pi out front. So my final answer would be 49 pi over 30. Now the only way they could change this question is if they put the axes of rotation, say, on the right side of this of these two functions. So let's maybe just set that up. So let's say now we have the same functions. So there's y equals root x which is the same thing as, in terms of x, y squared equals x. And then we have y equals x squared, which again is going to be root y equals x. And now let's say we are revolving this around a vertical line, which is somewhere here on the right, let's say at x equals 3. So if I draw my slice, now my outer radius is going to be this distance, which is going to be the curve y squared. Oops, I did that wrong, sorry. Again, when I'm figuring out the outer radius, I always go from right to left. So it's going to be the right edge of my parentheses 3 minus the bottom of the slice, which is y squared. And my inner radius is going to be this region right here. So that little r, again, is going to be 3 minus this curve in terms of x equals, which is root y. My limits of the integrand are going to be the same as before, so it's going to be the integral from 0 to 1 of capital R squared minus little r squared dy, which again, 0 to 1. So the outer radius this time is 3 minus y squared, 3 minus root y, and now I would evaluate that. So we'll quickly do the calculation here. Again, I'm going from 0 to 1. And it was 3 minus y squared. And that's all squared minus 3 minus root y, all squared. And I'm integrating that with respect to y. And that answer is 17 over 10. And when I times it by pi, it would be 17 pi over 10. All right, so that's how we revolve volumes of revolution around the y-axis. I'm hoping you found that helpful, and this would be your assignment for the volumes of revolution. When I say handout from the last two questions, I was referring to these last two questions right here. So 2006 number 1 and 2003 number 1. You could actually do even 2014 part A if you want to as well, just to give you some practice as well. So that is it for the lesson. Good luck. If you have any questions, feel free to email. Thank you.